some work that is done in work that is done in Ottawa as a development tool, not development tool, but development perspective. So please, the questions were, please share an example of a program or project that use remote sensing, and share maybe a perspective on how in maritime it could be used. So it's a remote sensing approach for shoreline detection and satellite-derived bathymetry. In Ottawa, there is a group in research. They work on a government-related initiative program, a proposal with the Canadian Space Agency, and some objectives are related to use to define the extraction of the coastline in a manner that we would be able to extract new features, or in some remote area, keep in mind that our cartography is not completed, so sometimes we have minimum of bathymetry, and recently in Hudson Bay, that group find out a new, not a new island, but an island that was not cartographed. So how can we use that methodology to define not new, but information that we don't have. So here the example that I will show, it's on the Mackenzie River. It's not in Maritimes, but it's really to be able to extract the coastal line. And as I said, I'm not the technical specialist, so I'll avoid the details on this, but really using the satellite-derived bathymetry, how could we define better the coastline, or how could we use it maybe to update more rapidly the products that we have to maintain. So the change detection, here it's Landsat images, and we'll just see the existing charts. That is, and again, we have products that are 40 years old, 50 years old, and it's common, I have to say. So with the satellite-derived bathymetry, we could see over the years how the island will move. In our case with CHS, it's really difficult. We cannot be there systematically every year, and the country is large, so where could we use that technology to apply in some specific areas? So it's almost disappeared here, and it could come back after that. So really, the test that will be done this year with that project, it's to use in some areas, and in Maritimes where we would be interested, it's really coast of New Brunswick, where sometimes within a year it changed significantly, opening inlet suddenly in dunes, sandbars, and we have also the same type of things in Prince Edward Island, the north of Prince Edward Island, and on the east coast. So that technique, it's just in development. It's not going to be used yet in production, but we're looking for that. That's just the speech I wanted to do.
All right, I have three quick examples of the way that we collaborate in, I guess, technology and then mapping in the U.S. Andy mentioned early this morning our collaboration, or my office, which was made up of Navy, Corps of Engineers, NOAA, and the USGS, and I'll put us in the running for worst acronym, but we're the Joint Airborne LiDAR Bathymetry Technical Center of Expertise, otherwise known as JALBATEX. And we've been around since 1998, and our mission is operations and R&D in airborne LiDAR bathymetry and complementary technologies to meet the airborne coastal mapping and charting requirements of our partner agencies. So we own government sensors that are operated by industry. Industry developed the sensors for us. We write requirements, and we have a long history of collaborating with industry and academia to advance our capabilities. So that was just one example. See if I can manage to do this way. The other way we collaborate is through our National Coastal Mapping Program. So this is a Corps of Engineers program, and the way our organization is set up is we have Our headquarters, so this is a headquarters funded program, but we have coastal districts all around the coast of the U.S. where we go and have planning meetings. And what this gives us the opportunity to do is let the districts bring in local stakeholders, and we present our plan for mapping, what we're going to do that year, and find out what everyone's requirements are, and within the confines of our budget and time and all of those things that we have in their area of the coast, we try and meet as many mapping requirements as we can through this National Coastal Mapping Program. On the data sharing side for our National Coastal Mapping Program, we of course put the data from that program into our enterprise database at the Corps of Engineers that we're working on getting online and publicly available. But we also make a copy of that data available to NOAA for their digital coast that Jamie mentioned during his talk this morning for public distribution. We give copies to the USGS for some of their coastal hazards work that they work on. USGS Eros Data Center has a web service for supporting hazards, the emergency response work. And then we also provide it to the National Archives that NOAA has at the National Geophysical Data Center. So we send out a lot of data on a lot of bricks, but we are sharing data and trying to get it to the public as much as we can. I think Jamie may have showed some of this morning, but this is the digital the DAV, the Digital Access Viewer, where people can go in, draw a box, and it'll automatically put the data on an FTP site for them and send them an email so that they can get a copy of the data. And this is just some statistics from this website. It's a really nice service that our partner agency provides for us to deliver our data to the public. So you can see the number of downloads from December of 05 to 14 of our data and some statistics. So I can go on a little website and get a report and see which data sets are getting used the most. So that's very nice. And then finally, building on the National Coastal Mapping Program and the JALBATEX, we have the Interagency Working Group on Ocean and Coastal Mapping, so expanding from those 4 agencies to about 26 other agencies in the U.S. government. And one of our main activities in the past couple of years is to put together a national coastal mapping strategy so that we can present that to the public and let them know what the opportunities are out there for collaboration. So we have an annual mapping summit. We've built developed some bathymetric LIDAR quality levels that kind of mirror some activities going on in the topographic LIDAR community in the U.S. We coordinate our data validation, stewardship, dissemination, and archive processes, and one of the main activities under that was to develop a metadata standard that's to be used by all the federal agencies when they're looking at airborne coastal mapping and charting data. And then finally, coordinating R&D on new capabilities for coastal mapping or ocean and coastal mapping. The strategy right now kind of focuses on airborne LIDAR, and we'll be expanding into other technologies, the sonar mainly in the coming year, sonar and imagery. And then I wanted to close with this as our federal mapping coordination site. All of the federal agencies have been asked to stand up a web service where all their mapping plans exist, so we can make that available to the public, and you can go click through. And through this site, we're also able to, or our stakeholders or state and local folks are able to go in and put their mapping requirements in for the feds to kind of consider as they're executing their mapping programs. So, and those are the quality levels, but I'll just skip that for now. But I'll leave a slide in so you can access it later.
Great, thank you. So I'm following Jennifer on purpose because she set me up for a little bit more discussion in terms of how we coordinate. And then you'll see that even though we're here in the same room, we didn't fully coordinate these presentations, but it's better to be redundant. So I have a slide in here that's going to talk a little bit about what she's discussed, but I'm going to show you a regional perspective of that. So hopefully there's actually still value. So what I wanted to start off with, though, was actually a product. It's a standalone product called the United States Interagency Elevation Inventory. And the story behind this really started after Hurricane Katrina came through in 2005. Everybody started scrambling, looking for the best available elevation data, LIDAR data, and there was no single source to actually find that information. And that kicked off an effort that continues today, which is to inventory all of the known LIDAR elevation data. So we started off by generating a map series of what we knew, what we could find, and we put that together. At the same time, or shortly thereafter, FEMA became very interested in inventorying LIDAR data for the entire country. And so they started that activity. And then shortly thereafter, the USGS decided, well, let's understand a little bit more about LIDAR and they commissioned an assessment called the National Enhanced Elevation Assessment, and there was a report produced as part of that that listed out hundreds of business cases for LiDAR and the value of LiDAR. So all of these activities started winding up, and then we decided, well, let's actually put together an inventory and partner with these other agencies and then maintain it. So what we have today is this online viewer that brings together everything we know about publicly available elevation data, not only LiDAR, but sometimes IFSAR data as well, the interferometric synthetic aperture radar for Alaska and some of the other geographies. And with each footprint, we have a series of attributes that can be queried so that you can understand the quality level, when it was collected, who has it, who the point of contact is, where you can get it, and things like that. So it's quite a rich database. Again, the partners include Army Corps, USGS, NOAA, and FEMA, and Forest Service recently joined the fray. So now we're going to be incorporating all of their information. We update this twice a year by reaching out through our network of liaisons. We've got regional liaisons through the U.S. Geological Survey, so we can update this twice a year. And you might notice that it actually includes data that goes offshore. So it's not just topographic LiDAR data or other elevation data, but we are considering some of the nearshore and offshore areas as well. So this has been a very successful project. That kind of set the stage for improving the coordination at an higher level, Jennifer's level, really. I mean, folks are talking about how we can integrate acquisitions and figure out planning priorities. And so that's where the IWG-OCM came in. And I wanted to include this slide anyhow, because look at the tagline up top. I've heard you guys in here talking about this in terms of the vessels and the offshore mapping. What was it? One mission, many measurements, or something like that. One visit. So anyhow, map once, used many times. And that's our motto for this particular effort. In the future, there will be more emphasis on the acoustics. And I'll skip over this. Well, maybe I will focus on this graphic. This is talking a little bit about how we're integrating the dry land elevation acquisition planning process with some of the stuff that's happening in the marine area. So you can see in the blue on the left, that's our IWG-OCM. That's the group that Jennifer mentioned. On the dry land side, the U.S. Geological Survey has been very engaged in putting together acquisition plans with state and other local agency partners, and that's called the 3D Elevation Program. It used to be called National Digital Elevation Program, and now it has kind of a new version with new partners and a slightly different mission, but really the idea is let's prioritize where we acquire data and try to find some efficiencies in how we cost share these acquisitions. So the 3DEP program, which is covering more inland areas, and the IWG-OCM, which covers more of the wet areas, are starting to integrate. They're starting to work a little bit more closely together. And they're actually using a tool that Jennifer showed, but I wanted to zoom into the Gulf of Maine Bay of Fundy area here. It's an application called C-Sketch, which you may have heard of before. But it's a nice collaborative platform that allows people to actually input their own information. And what we're looking at here in green are all of the areas where we have existing LiDAR data that actually meet a certain quality specification. And then those areas in gray do not meet those quality specifications. So that's a nice useful tool. We can see where we need to collect data to replace old data that's out of date or not as accurate as we'd like. And then in the blue, you can see where our Office for Coast Survey is starting to plan out some multi-beam surveys. This information is very useful for the state of Maine and for our regional groups to help leverage those acquisitions and possibly expand the areas to meet other requirements. So a lot of the information that we have is available via Digital Coast, and this is just showing, because we are kind of coastally focused, the Digital Coast is hosting a lot of the coastal LiDAR data. So in dark blue, after we've gone through that inventorying process, we've gone out and actually tried to get as much of that data as possible. And that's what we're showing here in dark blue. Light blue shows all of the data we are aware of that came out of that inventory. And I'll leave it at that.